Welcome to the dawn of a new era in air combat, an era where unmanned aircraft soar alongside piloted jets, teaming up to dominate the skies and transform the way wars are fought. Today we explore the U.S. Air Force's vision for Collaborative Combat Aircraft, or CCAs, an ambitious program blending cutting-edge software, advanced autonomy, and innovative engineering to reshape America's fighter fleet. Join us as we dive deeper into how CCAs might redefine tactics, technology, and overall air dominance for the coming decades. The vision for collaborative combat aircraft. The U.S. Air Force envisions CCAs as loyal wingmen for current and future fighter jets, semi-autonomous, uncrewed aircraft powered by jet engines. Their advanced design allows them to operate independently or in small teams, capable of missions ranging from air-to-air and air-to-ground combat to electronic warfare, targeting, and intelligence, surveillance and reconnaissance, ISR. At the heart of their operation is artificial intelligence, AI. The AI-driven systems allow CCAs to adapt mid-flight, working in concert with human pilots to extend battlefield awareness, optimize weapon usage, and enhance pilot protection. In theory, these platforms could be purchased and operated at a fraction of the cost of manned fighters, paving the way for a more robust, more versatile U.S. Air Force. Bolstering the Fighter Fleet Air Force Secretary Frank Kendall has underscored a planning assumption of building 1,000 CCAs, effectively 2 CCAs for each of 500 advanced fighters. This is part of the Next Generation Air Dominance, or NGAD, family of systems, which envisions a network of cutting-edge technologies. Beyond CCAs, NGAD may also include future manned fighters, advanced sensors, weapons, and more. To make this vision a reality, the Air Force requested $557.1 million in its fiscal year 2025 budget specifically for research, development, testing, and evaluation, RDT&E, on CCAs. Lawmakers hold the power to refine or reshape this request, signaling the program's fate. Once approved, it could dramatically accelerate the transition from concept to operational deployment, expanding the Air Force's reach and agility in future conflicts. But no program of this scale takes flight without debate and oversight. Policymakers must weigh the benefits of a larger, cost-effective unmanned fleet against the challenges of rapidly evolving AI, supply chains, and the shifting global security landscape. Changing concepts of operation. Over the decades, the Air Force's fleet size has declined, due in part to the escalating costs of developing, procuring, and sustaining new aircraft. CCAs offer a solution. At roughly one-third the cost of a standard crewed fighter, they promise not only a more extensive fleet, but also a new approach to combat training and sustainment. By relying heavily on virtual training, the Air Force aims to lessen the physical wear and tear on each airframe, thereby reducing overall maintenance expenses. The Air Force's need for a larger, more flexible fleet is driven by global threats such as China's A2/AD capabilities, long-range missiles, and advanced air defenses designed to keep U.S. forces at bay. CCAs operating alongside manned fighters could saturate enemy defenses, forcing adversaries to split their attention and resources among multiple targets. This adaptability aligns perfectly with the Air Force's vision of Agile Combat Employment, ACE, an approach that spreads operations across a network of dispersed bases rather than a few large, centralized hubs. CCAs positioned at these smaller outposts could serve as crucial sensors and weapon platforms, providing broad coverage in contested environments. By the time adversaries locate one forward base, CCAs could already be operating from another. Laying the technical foundations, years of targeted research and experimentation underpin the CCA concept. The Air Force Research Laboratory, AFRL, has led numerous projects aimed at refining the core building blocks, advanced autonomy, open systems architecture, and rapid digital engineering techniques. These initiatives reduce time from concept to prototype and ensure that CCAs can integrate new technologies without needing a complete redesign. One notable AFRL effort used 3 converted F-16s to test AI software in flight. The goal was twofold. First, to gather invaluable data on how pilots and autonomous systems interact. Second, to build trust and familiarity with cutting-edge AI in real-world scenarios. This knowledge feeds directly into the CCA program, informing everything from software logic to pilot training. Among the standout achievements is the XQ-67A, an experimental drone built by General Atomics Aeronautical Systems, GAASI. Designed for quick modification and low-cost production, the XQ-67A provides the template for GAASI's current CCA offerings, underscoring the Air Force's focus on affordability and adaptability over the traditional model of high-cost, highly specialized aircraft. CCA Acquisition Strategy. In early 2024, the Air Force launched its two-phase acquisition strategy for CCAs. Under Increment 1, 5 top-tier defense and tech companies, Anduril, Boeing, GAASI, Lockheed Martin, and Northrop Grumman, kicked off a design and build competition. By April 2024, Anduril and GAASI emerged with contracts to produce initial test units. Their work will lay the groundwork for procuring more than 100 CCAs in the next 5 years. But the Air Force remains flexible. Companies not selected in this round still stand a chance in future competitions. The service recognizes that multiple design solutions may be needed for different mission sets, some focusing on high-speed intercept, others on extended endurance or stealth. Increment 2 is scheduled to begin in 2024, potentially incorporating stealth technologies and welcoming new industry partners, including possible international allies. It's a signal that CCAs are not just a niche project. They represent a broad strategic push for U.S. and allied forces to collectively maintain air superiority. Specific company efforts. Anduril has been a rising star in defense technology. In 2023, the company acquired Blue Force Technologies, whose Fury drone quickly became a contender for CCA adaptation. The Fury platform's high-performance design, combined with Anduril's lattice software, an open architecture command and control system, positions the company to field a highly integrated and responsive aircraft. Meanwhile, GAASI builds on its proven track record with the MQ-9 Reaper and other unmanned systems. Leveraging the data from its test flights with the XQ-67A, GAASI is betting on endurance over speed, giving the Air Force a platform capable of persistent intelligence gathering, long-range strikes, and flexible mission profiles. The first CCA variant based on XQ-67A took flight in February 2024, setting the stage for swift production to meet Air Force demands. Funding and legislative oversight for fiscal year 2024, Congress approved $2.3 billion for NGAD-related research and development, a sum that includes $392 million specifically for CCAs. As the program's scope expands, so do the costs. Mid-year, the Air Force requested an additional $150 million to meet unforeseen expenses in quicken development. On Capitol Hill, lawmakers have tasked the Air Force with keeping costs manageable by using existing propulsion systems and maintaining modular, open architectures. These steps aim to minimize proprietary lock-ins and ensure that CCAs can adapt to new threats and technologies without costly overhauls. Future challenges and considerations. While CCAs hold enormous promise, obstacles remain. If the Air Force plans to operate hundreds or even thousands of these large unmanned systems, the logistics of storage, transport, and maintenance grow increasingly complex. Where will these aircraft be housed? Another pivotal question revolves around autonomy. As AI software advances, these vehicles will be capable of more independent decision-making, potentially outpacing human reaction times. The Air Force must decide how much authority to grant CCAs in combat scenarios. Will pilots still monitor each drone's key decisions, or will some tasks be executed without real-time human input? Striking the right balance between human oversight and AI-driven adaptability could define the future of ethical and effective warfare. Collaborative combat aircraft stand at the cutting edge of military innovation. If they live up to their promise, CCAs could expand America's fighter force, protect human pilots, and secure air superiority in ways once unimaginable. The confluence of advanced autonomy, scalable production, and strategic doctrine signals a paradigm shift in how the U.S. Air Force will project power. Yet the true impact of CCAs depends on critical decisions made today in Congress, the Department of Defense, and among defense industry leaders. Inside the U.S. Air Force's Collaborative Combat Aircraft, CCA revolution, long. Yes, it ends at join us as we continue to track this high-stakes evolution in air combat. But it should end at the era of collaborative combat aircraft has begun, and it may well redefine aerial warfare for generations to come. Remember to like and subscribe for more deep dives into cutting-edge military technology on combat tech, and thanks for watching.